Hi guys, we're back, and today we're gonna be doing something a little bit simpler, and it's to create the little balls that appear in some of the vertices here in this mesh, and we're gonna be giving them a little bit of a movement so they are not idle. In order to see this a little bit better, I'm gonna try to put the video again. So here we go. So you can see they're like in many of the nodes or vertices here in this mesh, you can see these little balls. We can actually, this is even, now that I see this, I think this is 1, 2, 3, 4, 5, 6 or 7, so maybe we need more, and we need to be more wiry, like not so thick. Yeah, that's actually, I think that's fair to do. So yeah. So being let's put it 0.05, and let's make it more like 13. I think that sounds about right. Created, yeah, it looks a lot. It's still a bit too big, I mean, but yeah, it's okay. Anyway, so with this, we're gonna be actually instantiating all these little balls in the vertices, and we're gonna be adding a controller to all of them, which is gonna be in the root. So one of the things we're gonna be doing before that is create a an empty object and 0, 0, 0. We're gonna make these a son of that, and we're gonna call these like fun sphere. Why not? This is gonna be the fun of all the things that we are gonna be doing. Okay, and we can have our little empty, which is gonna be node balls. For instance, we're gonna call them node balls. We're gonna make another folder, create another folder called prefabs, and we're gonna create a simple prefabs for the balls, which is gonna be a small sphere. Put in a 0, 0, 0. Create a material. Ball green. We're gonna go green. We're gonna make it you see these balls, they're not lit. I'm not sure if anything is lit in this scene, to be honest, but we're gonna assume that these wire mesh here, the wire that we did is lit, but these balls are not. We're gonna give them a flat color. That is unlit color, and yeah, I think we can use this. No, we cannot. See if I can put it in a different. Yeah, I can use that. So, well, think of this. Yeah. Damn it. Something like this. I think it should be a little bit less. Something like this sounds about right. And a little bit greener. Yeah, that's a little bit greener. Yeah. Okay. So this is going to be the green. We're going to have another one which is dark gray. And this is going to be something like this, yeah. So we're gonna be using these two materials, and if you look at the video here, it's like black or gray, green, gray, green, gray, green, and here green, gray, green, gray, green, gray. There is nothing here, gray, nothing here, gray, green, nothing here, green. So it looks like it's iterating every node. We swap, we go to the next one, okay? Which, yeah, sounds about fine. And you could think of these nodes where there's no ball to those where the scale is so low that you cannot see them. So that's again fine. So yeah, we're gonna be doing another tool. We're gonna be creating a new C# script, and it's gonna be little balls generation tool. And this one is going to be a little different, okay? Again, editor window. And this tool helps generate all the balls for a wire sphere. All the little that appear in the nodes of a wire sphere. Okay. So again, we're not having public and private attributes because it's a window. It's gonna be window methods, and okay, we're gonna be copying some stuff. So basically, yeah, why not? Let's do something like this. Yeah, and we're gonna be needing something like this. It's easier to start from something. We're actually gonna be needing some of the info from well, now that I come to think of it, we could actually how about if instead of creating another tool to generate the little balls that appear, how about we add it to the tool that we already have? Seems like more sensible, doesn't it? Like you need all the same, you need to put one in each of these nodes or intersections or vertices. So how about we generate them at the same time as we are generating this mesh? That sounds about right, doesn't it? So then what we need is a prefab of the sphere that we're going to be using. So basically we get this sphere, give them for instance, this one, and remove the collisions because we don't need colliders. And that's it. And it's like, we call it little ball, and create a prefab. There we go. We're gonna scale this ball later. You know, this is a bit too big. Compared to this 10. Yeah, this is a little bit too big. But I mean, this is probably the biggest that it should be. And the lower should be no, probably. But even 0.1 is going to be yeah, very small and barely visible, and then from there on. Good. So yeah, we got this prefab, and we're going to be adding more information here. So we're going to be adding the prefab, little ball prefab. We're going to be adding two materials. we're going to be adding an option to generate or not these little balls. Actually, I was going to set it to false by default. And then that's about it. So, oh yeah, and well, this a name. Actually, I don't think we need, but yeah, I don't think we need it. Like, we can have a private const string little balls root name, which is gonna be middle balls. Oh, and we need the scale. The minimum, the maximum, and yeah, I think that's about it. So that's the first part. Then we have to add all these parameters here. We can actually we can generate little balls. It's gonna be begin for that header group. So we generate little balls and so this way what we're doing is we are only updating this. Sorry, we're only showing the information about the little balls when we are actually going to generate them, which makes sense, right? What is the point of showing all that information if we're not going to be doing anything with it? So first, let's so the prefab. Basically, it's gonna be these little prefab type of game object and forced. We don't want to use scene objects. And the material. Gonna be the same type of material. Material force as material. Now you have the second one, and now I believe the scales. Yeah. Slider, we're gonna (0.0, 1.0) for instance, and max is gonna be the same. Good. So basically with this we are gathering all the information. And what we're creating here, this is the this part is going to stay the same, but then generate the little balls in the scene object. So in order to do that, we need to we need to keep the scene object, which is something that you have to return creating it, which is fair enough. We just need to do this, and so basically we're gonna create inside the wire sphere another the little ball's root. I'm not sure we actually need it. Actually, no, we don't. The root little ball OBJ name. Actually, yeah, I think this is all right. Yeah. Yeah. And if it's would probably be this would be like this. So basically, we're gonna add all of the balls as children of the scene object we just created. So we're gonna need something like. So we're gonna need something like private void create little balls game object root. And this generates all the little balls for these for the current parameters of the wire sphere. So yeah, basically we do these. Okay. So yeah. Since this is getting a little bit too big and a little hard to read properly, well, no, actually no. It's not too big. Let's move it here. So let's see. Let's see. Let's see if what I've done at least shows the right parameters in the editor tool. So got them. Are we done? Yeah, no, yeah, no. Good. It sounds like, yeah, this seems to be working, and then you should do something like this. One, and two. Yeah, sounds about right, and yeah. But still, it doesn't work yet. Yeah. So this is not going to be like this, and yeah. This is 0.05, yeah, so I'm gonna change the value because we're gonna be changing this script. I think it's good to set the values that are by default correct. Anyway, so let's create the balls. We're simply going to be iterating, doing an iteration like the one we've done there, and instantiating the objects in the right positions. So, yeah, we have to do this. I hate doing this. I think this is complete error. So, I mean, we could copy this code and it could just work, couldn't it? But it is not. It's always a bad idea to copy and paste code. If you're just going to be using exactly the same code, then I'm pretty sure there is a way of reusing it. And usually it's taking things out in a function. But in this concrete case, I believe that the best idea is to generate a list of nodes, because that's exactly what you're doing here. Yes, generating a list of nodes, and then each node is kind of, I mean, you got the position, and then with the position, you got the node. And then you do some stuff in the node, like generating the mesh, the vertices, and like the triangles for the node. But why not just generate a list of nodes? It seems sensible, doesn't it? So you can have something like out vector 3 nodes. So you basically, well, the number of nodes is gonna be something like this. So instead of doing these, what we're gonna do is this. And actually this is wrong. It is working, but this is wrong. And this is better. We can actually create here the nodes too. And we can go fit in it here easily. I num your steps plus IO equals plus. That's it. So now when we're creating the mesh, we have to use these nodes. Love it. There's a new feature in C# 7.0, I think, where you can declare the variable here. So, and this is all right. It's the same as we've done before with declaring it before and then passing it as an out variable. Instead, we're declaring it where we're going to be using it, and I believe this is very useful and convenient because. Really, many times when you're getting an out parameter, it's kind of like being able to use a tuple here, which actually you can in C# 7.02, but we don't want it here, or at least I think it feels alright to use an out parameter here. It seems sensible. So creating little values, you probably want to pass the nodes to. In this case, this is going to be very easy. So we're going to be iterating. With all the nodes. We're going to be instantiating, so we're going to be, for each node, we're going to calculate a random scale. We're going to be using here the Unity random. Do we want to use the Unity random here? No, I don't know, I don't want to use Unity random here. Let's use the system random. I'm not going to be using that. Maybe I'll be using this. So the system there is a random. And the seed, what is the seed? We're going to be using time now, time now ticks, yeah. So basically, we're using a number of ticks since the beginning of the time and counting here, which I think is, I don't know, somewhere in 1970s, 1980, I don't know. I don't care much. It's just the number of ticks, and this is going to be a seed, so it's going to be changing every time we click the button. So that's what is important. So it's a different seed every time, and this is a random structure, and random actually represents doubles, so we're gonna have to convert to float. Next double. and this is gonna be T. Scale is gonna be a lerp, min scale, max local scale, T. Okay, we got the scale now. Instantiate a new ball. So game object, new ball object is gonna be game object, instantiate game object, and the original is gonna be the little ball prefab. Now we're gonna give it a name. We're gonna give it a name like format. So basically it's gonna be a little ball obj name and the current iteration. This by the way is a way of saying, okay, this is an integer and I want you to put 3 digits even if the number is below 100. So it's going to be, for 0 it's going to be 000, for 1 it's going to be 001, for 7 it's going to be 007, etc. Place it in the right position and make it a child of root. That's important. New val obj transform, new val trans, new val obj transform, new val trans, parent is root. We place it in the right position, do the transform. Actually, we could cache the value and just always like that. I know it's just stupid optimization. It's just I'm so used to doing this sort of optimizations. It makes no sense doing it here because this is something that is done offline. I mean, even if the algorithm takes 1 millisecond more, it's not something that we're gonna be noticing. But I'm so used to doing this. It is a good caching things that you're gonna be reusing a lot of times. It's a good practice, and you know, if you always follow the good practices, it's a good idea. It's gonna make your code run faster in general. So place it in the right position. New ball trans position is gonna be nodes.I and apply the random scale. No, not all, and which is a new ball trans local scale. It's gonna be a new vector 3 scale. Assign the right material. So basically, render mesh renderer. It's gonna be new ball trans, new ball obj, get component, mesh render. If renderer is not null, then renderer material is gonna be I module 2 equals 0. Then we're gonna use mat1, otherwise mat2. So yeah, we're changing material every time, calculating the scale, and so on. Good. Yeah. Seems like we got everything we need. Let's go here. Let's assign everything again. We got 1, 2, 3, and everything else seems all right. There we go. I think 0.5 is a little bit too big, particularly there. 0.4 is going to be okay, I think. Yeah, that sounds about right. And you see here, you got all the little balls. There you go, and all the nodes. There's over 400 of them. Good. This is going to make it easier for me to explain something. So we can read it again. Yeah. All right. So the thing is, we have instantiated all these objects, but we haven't kept the prefab, which yeah, it's all right. So when we're instantiating things, we can keep the prefab reference. The prefab utility instantiate prefab I think. So let's use this instead of doing an instantiate, let's use an instantiate prefab. Let's just keep everything the same, but using instantiate prefab. It is likely to keep the prefab there, which is the reason we're doing this, right? If I recall correctly, that's the point of this. And let's see. So yeah, that's right. All the little balls have kept their reference to their the prefab, which is great, because that means that now we can change this prefab, and everything else is going to be changed. So, for instance, if we create a new component here, create a little ball component, it's a simple component that scales up and down the current object continually. Basically, max up scale, max scale is going to be in 1.2. Yeah, scale is going to be 0.8, for instance, and then we store vector 3 initial scale, although this is going to be given we're going to be given ini scale is going to be a transform local scale, and in the update have a public float period, which is going to be, say, 2.0. We're going to be needing a timer too. Yeah, variable and period, timer. The timer and update the scale. If it's bigger than this is in the first part, then we are scaling up. T equals 0.0 for So it's gonna be, yeah, no. It's gonna be timer divided by 0.5 f times period. Else it's gonna be t equals period minus timer divided by 0.5 f times period. This basically, if it goes 0 to 1 and 1 to 0. Then with this t, we just calculate the scale. This is going to be a lerp. Scale, max scale, t. Apply the scale. Transform local scale is scale times scale. That's basically it. This is just going to be scaling in and out, sorry, up and down the objects, big and small or whatever. So we can just assign this component here, and now if we click play, which then we see that it is working. It is working way too fast. By the way, let's move the camera outside so you can see. There you go. So when we hit play, we can see that this is scaling in and out. It's too big a difference, but it's all right. Well, so one of the things we can do here is, since this is a prefab, we can put 1, 0.9, and the period can be set to 5. But one of the things that still is going to be annoying is that all the balls are going to be like beating at the same speed and the same position. So wouldn't it be nice if each one had a different initial point? So we're going to be doing a another option here. We're going to randomize the initial scale. Then with the timer is going to be something like random. Here I'm using Unity's random, which is different from the random that we used before, and the reason to do this is because it's convenient. It's 0.0 and the period, and just like that, each one of these balls is gonna be beaten at a different point. Yeah, now they are all. See, this one is, I mean, they're not all growing at the same time and with the same parameters, which is good. This is very subtle, but it's exactly the effect that we were looking for. But now we have like 400 balls being updated. This is not particularly bad, but particularly because I got a good computer, but in the player it's even gonna be showing a little bit. Yeah, this is by well, this is the biggest cost in the behavior, because, well, this is the only behavior that is being run, but also it's 0.37 milliseconds. It's not a lot, but it's still, in a game, if you are gonna have, in our case, in this effect, we're gonna have like 10 or 20 of these. This is eventually gonna be a few milliseconds, and, well, I mean, I believe that we can improve slightly on this by simply doing the updates in a single manager. So what we're gonna be doing is create another script. This is gonna be a little boss controller, Okay. This is going to be a controller for little balls. It takes care of updating them in one go. So basically, we're not going to have many things here. We're just going to have a list or an array of little balls, which we're going to gather at the start. And we're just going to update them. But instead of using the update, we're going to have the update here. So float dt is going to be time delta time. Pass this delta time here. In here, what we're going to be doing is we're going to be adding a method that is going to be public. This is the actual update, and if we just move these here and we don't do anything else, it should still work. We haven't added this new controller anywhere, so it should be just fine. And this is still doing it. As you can see, it's growing and shrinking. Good. Okay, that's good. But now what we're going to be doing is take this out, and we're going to be doing it here. So basically, this is going to be our wire sphere, right? And it has a little valve controller. We're going to run it again. Everything is working, still working, but hopefully, yeah. Well, this is slightly better, not a lot better. It's not a little ball update here. It varied from 0.27 to 0.20, 0.32, 0.40, it's 0.33. And in here it's 0.29, 0.20. It's basically the same. It's not getting much out of it, honestly. The reason for this is because most of the problems that you're going to be having with this are going to be related to updating the transform. Anyway, there's an extra cost of calling this method, which probably isn't reflected here. I'm not sure. Calling each of these methods requires you to send an event, and an update on this being handled by and all of these objects. Now we're only handling it in one object here, which is a little bit faster, particularly if you're gonna remove 400. Sorry, if you're gonna have 20 of them, that means we're gonna have over 8,000 updates, which you're gonna convert to 20, which is a lot more manageable. It's not a big update, it's not a big improvement, but it's something that you should probably consider when you're having a huge amount of things that are being updated every tick. The last thing to do would be to ensure that when you generate a new one, you create the little balls in the end. We add the little balls controller to the root. Oh, by the way, I forgot. Everything that is an editor tool should go in a folder called editor, whether it's inside code or it's in the root, whatever, but it should be in editor. This, we will explain this further and maybe in another occasion, but this is important. Now we reload this. Now we have two projects because we have the editor project, which only has this, and the runtime project, which has this. That means that this part is not going to be compiled when we generate the executable, which is something we want to avoid because we don't want the editor tools to be compiling the executable. It crashes, but even if it wouldn't crash, you don't want that code there. It's only going to bloat the executable. So yeah, looks like we've got this working. Cool. Now we have a wire sphere with all the little balls. Great. Next time we'll be doing the parts of the sphere that are gonna be like the bands that we're gonna have in around the turning around. I hope you guys enjoyed this tutorial. If you liked it, please hit the like button below and feel free to leave any questions in the comments. And hope to see you guys in the next video. Bye.